And for the chromosomal aberration, take note that these are changes in the normal structure or number of the chromosomes, which leads to abnormality. So these are chromosomal alterations, and this would be resulting to what we call as non-disjunction. So what is non-disjunction? But before that, again, we have already talked about this. So what is the sex of the baby? Of course, you know that it's male because of the presence of the Y chromosome. What if this is normal, abnormal? As you can see already, it is abnormal because of an extra sex chromosome here. And for number 4, what is the chromosomal defect? The chromosomal defect is Klinefelter syndrome, XXY. So there's an extra X chromosome over here. So this is the normal karyotype. So just take note that they are two homologous chromosomes from chromosome 1 to 22, and then either an XY or an XX to finish the normal karyotype. So what is non-disjunction? So just take note that non-disjunction is the failure of separation, and there can be two areas where the separation can fail. First is the failure of homologous chromosomes to separate during meiosis 1, while the other one would be the failure of separation of the chromatids, meiosis 2. So this will be in anaphase 1, non-disjunction of the homologous chromosome. So you will see that one of the cells will lack chromosomes, while the other set of cells will have an excess of chromosomes. So this is non-disjunction during meiosis 1. On the other hand, this is non-disjunction during meiosis 2. So there is the failure of separation of chromatids. So you will have cells that have an extra chromosome, while cells that would have a loss of chromosome, while the other two would be normal chromosomes. So that would be the result of what we call as non-disjunction. So there are several types of chromosomal aberrations or abnormalities, one of which would be numerical, while the other would be structural. When we talk about numerical chromosomal aberration, this would be termed as aneuploidy, loss or addition of one or two chromosomes, while for polyploidy, it is the addition or the loss of whole sets of chromosomes. And for nullisomy, this is 2n minus 2, so there will be two homologous chromosomes that are missing, which is actually very lethal for diploids. Monosomy is 2n minus 1, mono meaning 1, somy related to loss. So this is 2n minus 1, and there's a gene imbalance because there is a need for two of these homologous chromosomes to produce the normal amount of proteins needed for the development of the organism. So monosomy is 2n minus 1. Trisomy is 2n plus 1, so tri pertaining to 3 copies of that particular chromosome. So you have already the two homologous chromosome plus another one leading to trisomy, and this is again because of gene imbalance. So you have only a certain amount that is normal, but because of the addition of the chromosome, you have extra proteins leading to abnormality. Alright, so these are the different aneuploids of the autosomes and aneuploidy of the sex chromosome. So for Down syndrome, trisomy 21 is extra. Edwards would be trisomy 18, that will be extra. Patau syndrome, trisomy 13 is extra. And while for the sex chromosomes, aneuploidy, Turner syndrome lacks one sex chromosome. That's why it's called monosomy X. Klinefelter has extra chromosome XXY. Metafemale is XXX and an extra X chromosome. And XYY has an extra Y chromosome. Now for Down syndrome, trisomy 21, there are 47 chromosomes, and you're already very familiar. Simian crease in the palm, mental retardation, upward and slanting eyes. For Edwards syndrome, there are 47 chromosomes, an extra one, and the extra is chromosome 18, and the characteristic is presence of cardiac and renal malformations, and difficulty, feeding difficulty and sepsis, and several other abnormalities in development. You have also Patau syndrome, as you can see in the picture. This is trisomy 13, 47 chromosomes, an extra one. So there are severe mental defects and defects of the brain. Most infants have cleft chip, congenital heart disease. For the sex aneuploidy, you have monosomy X, which is 45. So you have here the what we call as the shield type chest and the web neck that is very characteristic, and they are mostly most are sterile. For Klinefelter syndrome, you have XXY, that is 47 chromosomes, and then it has the person has mental retardation, and there are even XXXXY, which is 49, and XXXY, which is 48. Jacob syndrome is XYY, so 47 chromosomes extra, and the characteristic would be antisocial behavior, learning disabilities, and lesser points in the IQ compared with siblings. For the meta-female, XXX, there are 47 chromosomes, and they have no or minor mental retardation but have learning disabilities and have probably motor coordination problems as well. Now, finally, we have here the chromosomal abnormalities due to structural abnormalities. So this is quite easy. We already discussed this. So for the deletion, there's the removal of certain genes, making the chromosome smaller, and the reason it is abnormal or leads to abnormality because there is loss of genes, loss of function, loss of proteins, which is very important, or they're actually important, and its loss would cause abnormality. So you can see here a section is deleted and making the chromosome smaller. So one example is Cri-du-Chat syndrome, cry of the cat, because the baby a newborn baby who has Cri-du-Chat, the sound of his cry or her cry would sound like a cat crying. So this is a deletion at the short arm of chromosome number 5. So this is an autosome. On the other hand, translocation, wherein part of one chromosome is transferred to another. So there's an exchange. So that is what you call as translocation. Of course, it will lead to abnormality because changes in the reading frame of the gene can make the gene malfunctional, thereby producing no protein at all. So here is an example, is another diagram. So you can see here that there is indeed an exchange between two non-homologous chromosomes. So one example is the Philadelphia chromosome that would be exchanging parts between chromosome 9 and also chromosome 22, and because of that leads to leukemia. That's an example of translocation. Down syndrome carrier is another example of translocation. You have a normal amount of chromosome 21, but in this case, on chromosome 14, a section of chromosome 21 has been fused to it, so it's been translocated, thereby producing, technically speaking, 3 copies of chromosome 21, leading to Down syndrome carrier. So Down syndrome, there's also the manifestation of the Down syndrome characteristics as well. For duplication, one of the area is duplicated here. So there is an increase in the amount of proteins produced, and this will be leading to imbalance and also leading towards what we call as abnormality. So here's the duplication portion over here. And inversion would be where one end is inverted and attached again. So this again will be producing abnormality because the reading frame has been changed, which may lead to malfunction of the gene, producing the absence of proteins. Okay, so no proteins are produced. And that ends the whole of